For the 55th problem on the second ACT practice test, the equations of the two graphs shown below are y1 of t is equal to a1 times the sine of b1 times t. So that function is this dashed line here. And y2 of t equals a2 times the cosine of b2 times t. So that's this solid black line here, where the constants b1 and b2 are both positive real numbers. Which of the following statements is true of the constants a1 and a2? So let's first try and understand the basic roles that these constants a and b play in either of these sinusoidal functions. So let's first just look at the y1 of t, since if we can analyze and figure out what a and b are in this function, then those same properties would apply to this function. So let me rewrite y1 of t is equal to a1 times the sine of b1 times t. Now, this number out front, this constant a1, this number multiplied by your sine or cosine, this is what's known as the amplitude. So our a constants you can think of as the amplitude. And the amplitude is essentially looking at the graph, how far up or how far down your function goes. So in this case, we're looking at the peaks or the valleys. So the amplitude is essentially the difference between these two extremes here. So with our black line function, you can see your amplitude is considerably lower. So the function oscillates between smaller values. So in conclusion, this dotted line here, this is going to have a higher amplitude than this black line. And if the amplitude is higher, that just means that a1 here is higher than the value a2. So we can write that a1 is bigger than a2. And just to help you make a little bit more sense of amplitude, let's look at just the sine function and 3 times the sine function. So basically, this sine function, it's essentially going to oscillate on your graph between 1 and -1. But this 3 times the sine function, that'll oscillate between 3 and -3. So the peaks and valleys of this function are going to be much bigger than the peaks and valleys of this function. And this is a fairly rough sketch, but you get the main idea of what's happening. This function here is going to have much higher peaks and valleys than this function, just because the number multiplied by it on the outside is bigger. So with this in mind, now let's look at the constants b. So b1 and b2. And b you can think of as the frequency of your sine or cosine function. And frequency is a fairly simple concept once you understand it. It's basically how close are the peaks in your sine or cosine function. Or in other words, how close are the valleys to each other. And essentially, the closer these are to each other, the higher the frequency. So notice this dotted line function. These peaks here are further apart than the peaks on the black line function, which means that the frequency on this dotted line function is smaller than the frequency on the black line function. So the black line function is our b2, so we can say that b2 is bigger than b1. And now, to answer our question, all we have to do is figure out whether or not a1 and a2 are positive or if they're negative. And the way to do that is, let's first look at this dotted line function. So this is our sine function, and as long as you don't shift the sine function left or right, it'll go through the origin. But if the sine function had a negative number multiplied by it in front, then it would start going down first. But since we can see that it starts going up first, you can conclude that the constant a1 is positive. And you can make a similar argument for essentially this cosine function, this black line function, since the cosine, if it's not shifted left or right, will pass through a peak at a t value of 0. So when t is 0 in this graph, the cosine, as expected, should reach a peak when it crosses the y-axis. But if cosine was multiplied by a negative number in front, then the cosine function would be passing through as a valley when t is equal to 0. But we can see that that's not the case, so therefore this a2 would have to be a positive value as well. So a1 and a2 we can say are bigger than 0. And looking at our answer choices, you can see that choice letter B would be the correct answer.